Hi, I'm Carl, and in this video we're going to have a look at questions 16 to 18 of section 3 of the orange booklet. So these are the updated questions, and we're given quite a lot of information for this one, but it's a genetics question. So let's go through it. We're told that we're looking at two genes here and they're independently inherited. We'll come back to why that's important in a minute. And we're told that they control the colour of a feather. So we're told about two genes, one that controls yellow pigment. This is the dominant form, so we can label the recessive form with lowercase. And this is going to be for the yellow gene. But then we have the other gene, which is for the production of melanin, the darker pigment, which we're going to label with B. So what do the different combinations of these give us? So we're told that a green feather is where you are, where both are produced, so you're at least heterozygous for both dominant forms. And then the blue feather, we're told, is where you're recessive for yellow, but dominant for melanin. And then what if you were dominant for yellow and recessive for melanin? Well, we're told that recessive alleles produce no colour. And so if there's no interference, then we can just assume that yellow would be the other condition. Great. Okay, so question 16 says genes for the two pigments would most likely be what? So we're told that they're independently inherited, and that really just gives us the answer to this. Genes that are independently inherited have to be on different chromosomes. There'd be no way for them to be inherited independently if they were on the same chromosome. So that's really the definition of what independently inherited means. It means they're just on different chromosomes. So 16 is going to be B. So 17 is asking us to do a cross. It says, what is the expected phenotypic ratio of a cross between the two genotypes that are given? So let's have a look at those genotypes. The first one is going to be heterozygous for both. So what alleles could be passed on? So remember, these are two separate genes. So you could get one allele from both. So you could have the dominant allele or the recessive allele from either side. So that would give you these four different options here for that first inheritance. But what about the other one? Well, this is where you're going to be homozygous recessive for Y and then heterozygous for B. So what are the different alleles that are being produced here? Well, you have to be recessive for Y, but you could be either with B. So if we crossed these different possibilities, what would that give us? So I'm just going to move down a little bit further here. So the two options we've been given, just for sake of simplicity, we'll do it like this. Let me just draw all these out here. Okay, so if we do our cross, what are the different phenotypes that are produced? Once we've done this, we can count them up and then work out the ratio. So first of all, we'll start up here in the top left-hand corner. And we're going to be heterozygous for Y and then homozygous dominant for B. And if we move across, then you're again going to be heterozygous for Y and heterozygous for B. Next, we've got homozygous recessive for Y and homozygous dominant for B. And then heterozygous for B. And then heterozygous for Y. And again here, but homozygous for B. Then we've got finally homozygous recessive for Y, heterozygous for B, and our final one here is going to be homozygous recessive for both. So what does this mean for our different phenotypes? So let me color code them. So we're going to look for the green ones now, which is where you're going to have a dominant allele for both. So that's going to be this one. This one. Yeah, that's them all. So we've got three which are green. So blue is where you're going to be homozygous recessive for Y, but have a dominant allele for blue. So that'll include these ones here. So we've got three blue. And then finally we've got one yellow here. Sorry. Have we? Yes, that's just one yellow here, because I hope you can see that, you're just got one dominant allele in the Y, but you're heterozygous for Y and homozygous recessive for B. And then finally we've got this weird one here, which is where we've got no pigment produced, so 1 for no pigment. So that's not really going to be included in our ratio. So if we had a look then, or we could say that this one is white, looking at the question now, and it would lead to a white. So that gives us a 3:3 to 1:1 ratio, and that's going to correspond to answer C. Then, so question 17 is going to be C. And we've got one last question, which is question 18. And it says, suppose the mating process produces fraternal non-identical twins. Which one of the following is true with respect to the feather colour of the offspring? So let's go through these. A says the offspring cannot have the same phenotype. So there's no reason for them not to be able to have the same phenotype. It is possible. B says the offspring cannot have the same genotype. Well, if they have the same phenotype, then it's possible, but they don't have the same genotype. C says the two offspring and two parents could not all have different phenotypes. So that one's a little bit trickier, because you need to think about what the potential genotypes of the parents would be. It's hard, and also their phenotypes. But if we look up here, we can see that there's more than one way to have the same phenotype. So there's 3 different options to have green feathers, for an example. So that's not necessarily going to be true. And then D says the offspring could both have the same phenotype and genotype as one parent. And that's going to be the answer here, because as you can see, there's a number of different combinations you can have here. And they could have the same genotype. Just because they're non-identical, it means they could be non-identical for another gene. And because there's lots of different ways of having a particular characteristic, they could indeed have the same phenotype. Now, for them to have the same genotype as one parent, it means that the other parent would have to have a complementary genotype to deal with that. It is completely possible. So the answer for this one is going to be D. So that was questions 16 to 18 of section 3 of the orange booklet. I hope that helped. Thanks for watching.